how we find the center. Number 20 is a little more complex. You have a total width up here of 10 feet, but if you notice, all your other measurements are in inches. So the very first thing we're going to do is we're going to convert this from feet into inches, and so we multiply it by 12. So let's think of this as 120 inches. It says Sheldon wants to hang a picture in his bathroom. You know, Sheldon would be very, very precise about where that picture goes. The picture is 12 inches wide. The entire length of the wall is 10 feet. The door is 36 inches wide, and there is a window that is 32 inches wide. The space between the edge of the wall and the window is 5 inches, and the distance between the opposite edge of the wall and the door is 10 inches. And if you look at the diagram, you can see all those things that were just listed there. If sometimes the wording gets too much, then you may want to take a minute, read a sentence, identify it in the diagram, and then work back and forth between those two things. How far from the edge of the window does Sheldon need to measure if he wants to center the picture? And you notice right here it says that's where he wants to center the picture. So I've got to find out how much space I have right there. How many inches from the edge of the window right here over here to the edge of the door. So I've got to get rid of this and this and this and this. So I'm going to take my 120 inches and I'm going to subtract those. Now, depending on how you want to do it, you can subtract one thing at a time. So you can say 120 minus 5 is 115 minus 32. My pen's being difficult, not wanting to work with me. That would give me 83. And then I can subtract the 36. And that would give me 47. And then I can subtract the 10. And that would leave me with 37. Another alternative is to do the opposite, to add 5 plus 32 plus 36 plus 10. And then take that answer and subtract it from the 120. So when we take those numbers and we get the 37, then that's where we can start looking at how we're going to center that. And again, guys, remember when we center, we're going to take the distance left, and we said that that was going to be 37 inches. And it says, how far from the edge of the window does Sheldon need to measure if he wants to center the picture? So if I take the 37, that distance, and I take and divide it by 2, then you will end up with 16.5 or 16 1/2. I think that that is an incorrect answer. I think I just told you all a big fat story. Be 18.5. Alright, that looks better. 18.5 inches. Sorry for the confusion, guys. When we look at 21, 21 looks like it's kind of scary in some ways, but you all have done these before. What we're doing now is the only thing that's really different from 6th grade is we've thrown a negative number in there. Remember, when you multiply or divide, if your signs are different, you're going to have a negative. So we're going to start with this part right here in the front. The reason I'm starting with this, we're using our order of operations. Order of operations, multiplication and division are equal to one another. So I'm going to take negative 4/5. Remember, you never really divide by fractions, you multiply by the inverse. So I'm going to change it to multiplication, and then I'm going to use the inverse fraction. So instead of 2/3, I turn that upside down and make it 3/2. That number right there is going to give me negative 12 tenths. Now I have a decision to make here. 12 and 10 can be reduced. We can make that into an equivalent fraction in lower terms. So we can divide both of those by 2. If you do that, you would end up with negative 6/5. This might be helpful if you sometimes struggle with your multiplication facts because you're dealing with lower numbers, and most of us have learned our 1 through 10s facts pretty well, so that can make that easier. It is not a required step, but it can help you, and it is a possibility. So now I'm going to take that fraction, and I'm going to multiply by the 7/8. Remember, when we multiply, we're just multiplying numerator times numerator and denominator by denominator. So -6 times 7 is -42, and then 5 times 8 is 40. Now, we want to go ahead and reduce this. You do not have to make it into a mixed number, but we do want to go ahead and reduce it. And the way that we're going to do that is we are going to divide both of these by 2. And when I do that, I'm going to get -21/20ths. And that is the correct answer. On the next one, I have got some work here in parentheses that I need to take care of first. So I have 4/3 minus 5/6. So I'm going to go ahead and take care of that first. So 4/3 minus 5/6. But remember, when I add and subtract fractions, I have to have my common denominators. So in this case, it's going to be a 6. So the second fraction will stay as is. Then this one right here, if I have to multiply this times 2 to make that a 6, then I multiply times 2 here, and that makes that 8. So now 8 minus 5 is 3. Denominator stays the same. I can go ahead and reduce this and make that into 1/2. So now I have 4 times 1/2 times -3. So I'm going to start right here with the 4 times 1/2. So I can set this up as such. So 4 times 1/2, so 4 times 1 is 4, 1 times 2 is 2. This can be simplified to 2/1. And again, when you multiply by 1/2, that's the same thing as dividing by 2. So I could have also said 4 divided by the whole number 2. Now I'm going to multiply that by the -3. And I'm just going to put that in fraction form since I have the fraction here. You could go ahead and change the 2 to a whole number if you'd like. So 2 times -3 is -6. Denominator stays 1, and so that would just equal whole number -6. Excuse me, guys. Alright, so we're going to pick up with 23. Question number 23 has, again, it's order of operations. You have fractions. You have some negative numbers mixed in, but the basic core idea of order of operations is still going to be the same. So we're going to take what's inside the parentheses and we're going to solve that first. So then I have 3, and then I'm going to use my common denominators of 20. So I have 24/20, and then I'm going to go ahead and do the same over here with these. And again, common denominators here, we will have 40, so 24. I'm trying to make everything fit there. Now we can take care of what's inside the parentheses. So 24 plus 5 gives me 29. So I'm going to bring the 3 down, and this is going to become 29/20ths. Connect that there. And then you're adding to it, you have this -2 multiplying what's inside the parentheses, and what is inside the parentheses is 39/40ths. So now I've got to take care of multiplying what we have here. Before we can add them up, we have to multiply because of the order of operations. And so on the first one here, you're going to end up with 87/20ths. And then on the other side of that one, you are going to end up -2. Let me pause for just 1 second. Okay, sorry about the pause there, guys. So I'm going to take the -2 and multiply it by the 39/40ths. At that point, I'm going to get a negative number because I have a negative times a positive, and that is going to be a negative, and you're going to end up with 78/40. Now again, all I'm doing right now, even though my numbers are large, all I'm doing is I'm adding these two fractions, which means I have to have common denominators. So I'll change this one to a 40. this fraction over here can stay the same. I'm only putting the parentheses on this because it is a negative number and I don't want those two signs to get confused. So if I multiply this by 2 to make it into the 40, I have to multiply that by 2 as well. And you get 174. So now, when I take those two fractions and combine them with common denominators, 174 plus a negative 78 gives me 96. And I'm just going to bring down or bring over my denominator of 40. At this point, you do need to reduce or transform it into its lowest terms. An equivalent fraction, of course, it's in lowest terms. So when you work all that out, you would end up, if you want to use the mixed number, you're going to have 2 and 2/5, or you could write it as 12/5. Either one of those would be acceptable. So now let's take a look at number 24. So it says that we're going to divide everything upstairs by the 1/5, but that means I've got to do all the work upstairs first. So when I look at the 17 minus 1/2, that's going to come down as maybe 16 and just have to use my finger here and 1/2, and then you are 10, and then inside the parentheses, when you take the 2/5 and you add the 1/4 to it, again you're going to have that common denominator of 20 like we did over here in the other one, and you're going to end up with 13 over 20. So now I've got to multiply those two things before I can do a subtraction. So 1/2 times the 16.5, or if you wanted to convert it at decimals, you could also do that. You could change it to 0.5 times 16.5, and you end up with 8 and 1/4. And then over here, when you multiply 10 times 13/20, you are going to end up with 6 and 1/2. So I've got to get this down. So when you take these two things and subtract that, you end up with 1 and 3/4. And then again, you've got to divide that now by the 1/5. So at this point, again, if you want to convert to a decimal, you're welcome to. You would end up with 1.75 divided by 0.2, but you can also keep it in this form. So I'm going to take my mixed number in the numerator position. I'm going to convert it back to an improper fraction. So 4 times 1 is 4, plus 3 more gives me 7. So I have 7/4 divided by 1/5. So I'm going to rewrite that, and I'm going to, remember, we don't really divide, we multiply by the inverse. So change this over, and 7 times 5 would be 35/4 on the bottom. So can I leave it like this? Yes, you can. If you want to convert it into the mixed number, that is okay as well. If you choose to do that, you could either keep it like this. Those are positive. Equal sign kind of right over there. You could change that to 8 and 3/4. So either one of those answers would be acceptable. Last stop, guys. I know that you all have put up with me for a long time, and I appreciate you waiting through this video. So last thing we're going to do is we're going to look at equivalent expressions. So when I look at this right here, when I use my distributive property, I end up with 9x plus 27. So I'm going to see anything that when I either simplify it, use distributive property, whatever, anything that will come back to the 9x plus 27. And in that case, you have a, obviously that's clearly stated. Then you also have 3, because 3 times 3x would be 9x, 3 times 3 would be the positive 27. So you have a and c. Now on 26, I don't have a distributive property, I just have the 25p plus 20. So I'm going to look at these. The only way to really solve this, it's not a trick question, you're going to use the distributive property to see what you get for all of your choices and see which ones are equivalent. And on this one, you have a and c as well. When you look at b, b does not work because you would end up with 5p plus 20, not 25p. And here you have 5 times the 5, but that 5 is negative, so this would be negative 25p plus 4, and that is not equivalent.